Good evening, everyone. Am I audible? Okay, I guess I am. So, uh, we are one third, like our course is one third completed. So, we are entering the second month of the course. It is 12-week course. So, this will be the week of the discussion online assessment. So, till now, we have studied about many things. We have studied about reactors, the quality of water, wastewater, how do we do sedimentation, the grid chamber, secondary sedimentation, the properties, everything. So, adding more towards it. So, this week we'll discuss more things in that direction. So, I am Mansi Tripathi. I am TA for this course. So I'll share my screen now. We'll see some questions. You can solve it with me, or also whatever questions you have, you can ask in between or at the end. So I'll share my screen now. I think it's not coming proper. I'll reshare it. Okay, it's coming proper now. So this is water and wastewater treatment. We are entering the fifth week. This is the problem solving session. And this is a little of my intro. I'm Mansi Tripathi. I'm a research scholar at IIT Madras. So we'll see some questions and we'll try to solve them. So this is a problem statement. After this, we will have three questions on the same. So it's better if you can note down all the things, all the details that are present over here. So consider a municipal wastewater treatment plant. It uses traditional activated sludge process. I guess by now you know what is activated sludge process, and when we say traditional activated sludge process, it means it is just an aeration tank as well as sedimentation tank with recirculation. There are no membranes inside. So this is what we call traditional sedimentation tank. We have the population of the village. This is to we are giving the population to calculate the design flow. Sewage generation per capita. These are number of people. This is sewage generated by one person in a day. We have influent BOD. We have MLSS means X. We have this S naught. First order death rate constant also we have. Specific yield. I hope you remember what specific yield is. So what is specific yield? It is biomass produced and food consumed. I will write like this. So it is saying 50% of the food is consumed to produce the biomass. Assume that PCB enforces a treated wastewater. This is uh, CPCB, Central Pollution Control Board. Enforces a treated wastewater standard of BOD 5. What is the BOD 5? This is the standard. So this should be the final BOD and suspended solid of 20 milligram per liter. So please, first of all, I'll give you 2 minutes to note down all these values. Anyway, I'll share the slides, but it's better if you will solve it together. Please note down the values. I hope you have noted down the values. So we'll move towards the question. So the first question is, if the tank volume of if the volume of reactor tank means the ASP, where aeration is taking place is this. What is the volume? Volume is 325 meter cube. Then the hydraulic retention time. I have previously explained what is hydraulic retention time and what is solid retention time. So here we are talking about hydraulic retention time, means we are talking about the water. We have to calculate that in hours, and if it is solid retention time, it will be given in days to achieve the required quality of treated wastewater. We have the volume of reactor, we want to calculate the theta. What will be theta? It will be V by Q. And how we will calculate the Q? From the population multiplied by wastewater. So this is the hint. I have given you all the formulas. Please try to calculate theta. And if you have already calculated, we will match the answer in a minute.
It is 2.167 hours, ma'am.
Okay, we'll check. So your answer is very correct. It is 2.167 hours. Okay, so this is how we will calculate Q. We have the volume and theta. It's very easy. Time is equal to volume divided by discharge. So this is what we get. So your answer was correct. Let's move towards next question. The next question is the average time for which biomass stays in the system. As I have already explained, when we talk about the solid retention time, so here the biomass stays in the system is the solid retention time. It will be always given in days. Sometimes in exam, what will come? We will just give questions. There will be two retention time. One will be in days, other will be in hours. So you have to identify which one is which. So be very careful. I am repeating it multiple times. Solid retention time will be in days and hydraulic will be in hours. So please, we have a proper formula for this question. It is already derived. So please try to answer this question. Then we'll see the answer. Okay, enough time has been given. We'll see the answer for this question and the formula. So here we will like these equations are already derived, but here again we have given the equation. So first we will do the material balance. So whenever you can remember these formulas also, but it will be better if you just remember the derivation. When we talk about ASP, there will be balance of the substrate and balance of the biomass. So we will consider one balance at a time. This is ASP. After that, the line will go to sedimentation tank. One will go outside as an effluent, another will come as return flow. So while solving such question, always remember either we will mass balance this substrate, okay, that is BOD, or this X biomass. So one at a time. So here in this question we have balanced it. Okay, so this is the equation we got. Sir has very properly explained how this is derived. Just we have to put the values given in the question. We will put KD, we will put theta, that is retention time. Here what we found 0.09 zero 0.09 days, so that is around zero point 0.1 days. So same 0.1 days. Okay, so this is nothing else but the same which we have derived in the previous question. S naught, as I told you, this is material balance. S naught, S, what we want here, this is S naught. Y yield, already explained what it is. X is MLS's concentration. So this is what we got, theta C. So what is theta C? Actually, it is the time till which solid is remaining inside the system, the suspended solids or the biomass. Some biomass will be here. After some time, it will go in this tank, then it will come back. So while coming back, there will be some biomass. What we consider that no biomass is going outside the system. Okay, so this Xe we consider as 0. That is why we consider that all the biomass are coming inside the system. So for how much time a single biomass is remaining inside the system is 2.896 days. Okay, let's move towards next question. Continuation of the same main question. If the microorganisms reaches half of their maximum growth rate. Okay, so what is half of maximum growth rate? Mu is equal to mu max by 2. When BOD5 concentration is 120, then the maximum growth rate is, now we have to find the maximum growth rate. We have to find this mu max. So the organism is reaching half of their maximum growth rate when BOD5 is, means mu is equal to mu max by 2 at S is equal to 120. So what will this mu? We have very clearly defined formula for this, or you can use the derivation itself. So it's your choice, whatever you want to use. Try to answer this question.
Ma'am, it is 2.76.
Okay, we'll see. Yes, your answer is very correct. It's 2.76. So this is the formula that we will use for substrate. These formulas have been very nicely derived in the ASP problem. Okay, so this is how we will get mu m. So this is mu m is mu max that I have represented here. So this is how we will get. So moving towards question number 4, which is a new question. So this is question number 4. Here you have to tick the options, and there can be more than one option. So here the question is, why is this highlighted range? So this is the highlighted range. Why it is the best range for operation of in ASP process? Why in ASP process we operate in this range? Why not in exponential growth? Why in this area? So this is a mixture of stationary phase as well as phases are already mentioned here. You can see this is talking about rate of metabolism, endogenous phase, declining growth phase, and exponential growth phase. So why it's better to work in this area in case of ASP? We can discuss the correct option. There can be more than one correct answer. I'll give you some time to think over this question. Okay, this is one of the most important question. We'll see the solution. So the answer is first, this zone is between declining growth phase and endogenous growth phase. So here what happens? We do not want all the bacteria to die. So this is declining growth. Some bacteria are in stationary phase, some are in death phase, endogenous growth phase. So, and why we want this situation? Because here food biomass ratio is not too low nor too high. If the food ratio is too high, food to biomass, there will be more BOD going into the effluent. And if it is too low, then what will happen? Okay, then there will be more microbes that may cause some interference. Okay, so at this phase, microbial growth has slime layer. So when there is what happens, there are many particles, discrete particles, let's say, and there are microbes. So a flock will be formed around them. When there are too many microbes, so there will be less space between them. So this organic particle can get trapped here, and it will be easier for them to settle down in the secondary sedimentation tank. So this phase is beneficial when we go for settling. This process is fine at any phase. It's workable when we are talking about the aeration tank. But when we talk about the settleability of the sludge, then this phase is better, because if the bacteria are in the log phase, it will eat more food. But what happens at the log phase of bacteria? The size of the bacteria is very small. At the log phase, bacteria are smallest. So what happens? Bacteria won't settle. They will go inside the water. So they may end up in effluent. That is why we prefer this phase, endogenous and declining growth phase, because here the size of the bacteria is much larger. They will form slime layer. So they will settle down. They won't end up in the effluent. So this is the only reason to improve the settleability of the sludge we perform is at this range. Moving towards next question. Facultative bacteria are able to work in. So we are talking about facultative bacteria. This is a very basic question. They should be asked in the first chapter itself. So I hope you know answer to this question. So facultative bacteria are able to work in.
Option C, ma'am. Presence as well as absence of O2.
Very correct. And if I say obligate anaerobes, obligate anaerobes and obligate aerobes. Can you identify the difference? What is obligate anaerobes? Obligate aerobes? This is nothing else but the anaerobic and aerobic bacteria. Obligate anaerobes means if there is little oxygen. Okay, when we say anaerobic bacteria, they can survive in some amount of oxygen. Okay, not very high, but if something is there, it's fine. But when we say obligate anaerobes, if there is more than 0 milligrams per liter of oxygen, they will start dying. And opposite for this thing, obligate anaerobes, below a certain level of oxygen, they are gone. So obligate means oxygen is necessary or not. Okay. If I say obligate facultative anaerobes, like there are various terms like this. There are some bacteria which are facultative in nature but more towards aerobic side. But there are some bacteria which are facultative in nature but more towards anaerobic side. For example, methanes. In case of methane, methanogens. So they are like they are totally anaerobic, but there are some bacteria which can live in both, but they will grow better. Means when they are facultative, they can live in both conditions, aerobic or anaerobic. But in some cases, but their sizes will be small. But there are more if they are more towards anaerobic, their size will grow in anaerobic condition. But they can live in aerobic also, but with smaller size. So by looking at the size difference, we can identify even if they are facultative, they are more aerobic or more anaerobic. So this is how these types of questions are formed. Next question is kind of same question. What I have already explained. You can answer this question very easily. Here we have to match different types of bacteria: anoxic, heterotrophs, anaerobic, and autotrophs. Try to answer this very simple question.
Ma'am, it is option D.
Okay, we'll see. Answer is option C. How? When we say anoxic condition, um, then means okay, I'll tell you. When we say anoxic condition, then it means there should be no oxygen, but other organic sources like nitrate can be there. Okay, but when we say anaerobic condition, so we want no oxygen even from these. Okay, no oxygen, zero oxygen means there should be nothing, just organic sources. And autotrophs and heterotrophs are simple. Okay, so that's why what you told it was little wrong. Okay, rest of the things it's very simple. So when we say anoxic, we mean in a water there is 0 grams per liter of oxygen, but there can be 10 grams per liter of nitrite, all these things. So anoxic bacteria can take energy and a material from these oxygen. But in case of anaerobic bacteria, they do not want anything, no oxygen, even in the inorganic sources. Okay, so there will be a list of all these kinds of terms and their description. Please learn that properly. Next question is, select the correct statement about nitrogen removal process. Here we are trying to remove the nitrogen. I have given a kind of nitrogen cycle also. So please try to identify all these statements which are correct. And there are more than one answer. Think properly. Okay, we'll see the solution. So the option first is option A and option B. Option B is very correct. From conversion from organic ammonia that is present in dead and decaying matter of plant and animal, which is converted to ammonia nitrogen in the form of gas or in liquid also, which is converted to nitrite. Okay, there will be one bacteria which will do this. I hope you know the name. And there is another set of bacteria which will convert nitrite to nitrate. So there are two types of bacteria here. If you know, you can answer in the chat box. Then nitrate is converted to nitrogen gas. 1 gram nitrogen requires 4.757 gram of oxygen. How? This same process. This ammonia needs some oxygen to first convert to nitrite, then to nitrate. So in this process, oxygen required is 4.757 grams when we want to convert 1 gram of nitrogen. So both these statements are correct. So these bacteria, if you know, please write in the chat box. We'll move towards next question. Select the correct reasons which cause bulking of sludge. So what is bulking of sludge? I already explained, we want to increase the settleability of the sludge. So this is the container. We want sludge to be till here. Very good sludge. But when the sludge bulks, it will be here, till here. And it may sometimes go in the outlet also. So this is what we call sludge bulking. So what is the correct reason which causes sludge bulking? Please try to answer this question. I have already explained this. गए हैं बाहर तो हमारे लिए तुरंत से मिष्टी रानी क्या कहती है, ये लेना चाहता ब्यूटीफुल। हम कहे अच्छा अच्छा तुमको यही सुंदर लग रहा है, लो लो रख लो। देवाशी बच्ची भाई हम आपके लिए दूसरा ला दे। वो दूसरा हमको आज तक मिल रहा यार, हमको किसी चीज की कमी नहीं है, लेकिन प्यार का ना हो ऐसे करके अभी तो मिष्टी के हाथ का पनीर दूध प्याजा खाइए ना तो आप पागल हो जाएंगे। बताओ मिष्टी से पनीर दूध प्याजा खाइए, चार प्याजा खाइए, अब खाओ। देवाशी को हमारे सिर दुखता था तुरंत तेल लेकर के आ जाते बच्चों की तरह, अभी थोड़ा चंपी कर देते। कल हमारे सामने बैठ के देवरानी जी से हमारी मिष्टी रानी से तेल लगवा रहे थे और तब क्या कर रहे हैं अभी मिष्टी लगी बहुत बेस्ट मसाज कर मिष्टी बेस्ट, अब भाभी बेस्ट, इतना ही बेस्ट खा और गुजिया में डाल और तस्वीर लगाओ बेस्ट मिष्टी बेस्ट। Okay, we'll see the answer for this question. So first is I have told you the sludge. This problem should not be too high or too low. The F by M ratio. So when F by M ratio is too high, means food is more, biomass is less. So the organic matter will still remain inside the water. And if the sludge ratio is too less, okay, then there will be microbes which will be of smaller size. So they may bulk, and high sludges when the microorganisms age means the recirculation ratio is very less. Okay, so they will keep on rotating inside this aeration tank, then there can be formation of some filamentous bacteria. Okay, we prefer small bacteria, but due to this filamentous bacteria, due to their interference, the sludge may rise. So high sludge age means it is directly related to the growth of filamentous bacteria. So because of them, the sludge may bulk. Moving towards next question, question number 9. Select the correct statement regarding food by biomass ratio. Same question. So these are four statements. We are talking about some high and low food by biomass ratio. Please, we have discussed enough, so I think you can answer this question. Okay, please try to answer this question and think over it very properly.
Ma'am, it is option B and C.
Okay, we'll see. So the yes, you are very correct. It is option B, A, C. Food by biomass ratio for endogenous phase is lesser than exponential growth phase. Of course, it's very correct. When endogenous phase, food by biomass is less. So that is why they will feed on each other rather than feeding on the organic matter, means feeding on the food. In low food by biomass ratio, cells get starved and nearly all substrate get consumed. So same thing. This is option C is just the explanation of option B. So we'll move towards next question then. Arrange the characteristic growth phase of pure culture of bacteria in current sequence. Here we have to arrange them in correct sequence. This is very easy question. You have to just plot the growth curve, how this will happen. Please try to answer this question. So I'll make a graph for you also. This is how it will start, then it will go up, then like this, and then like this. So what phases? This can be the number and this can be the time. What are these phases? Please try to answer this question. जानते ही नहीं है यहाँ पे यार। हम बॉलीवुड में नहीं है यार। अरे यार तो कुछ 5 मिनट लग भी नहीं है यार। अचानक खाना कौन बनाएगा? खाना इसको बोलना। ए भाई मैं तो सिर्फ चाय बना। चाय बना? मैं मैगी बना सकती हूँ। बहुत ज्यादा नहीं, वो सब छोड़ो भैया। क्या यहाँ पे कोई स्टारबक्स है पास में? स्टारबक्स स्टारबक्स। अरे नया जगह है रे। इधर कोई क्रिकेट खेलने को आता भी रहेगा क्या पब्लिक? हाँ ना भाई, इधर कोई अपने पेशेंट का। क्या प्लान सोने के पूरा दिन? Okay, we'll see the answers for this question. The first is exponential growth phase. So in this diagram, there are more growth phases, but here it is not represented. So this is lag phase. This is log or exponential growth phase. Log or exponential. This is declining growth phase. Now coming towards stationary phase. Stationary phase, it's very clear from the word stationary, means growth and death are equal. Now this is endogenous phase. I hope there is no doubt in this question. Lag phase means when we are putting bacteria in a new environment, what will happen? They won't divide. They will just remain stationary, but they will grow in size. So at this phase, size of the bacteria is largest. Here size increases, but number remains constant. Here they will just try to acclimatize to the new environment. Then when they are properly acclimatized to the new environment, in log phase or exponential phase, what happens? They will divide. So binary fission or anything, most commonly we consider binary fission. So in this phase, they will divide exponentially. Then in this phase, declining growth phase, there will be more formation, more generation, less death, but generation will be little slower and death will be little more, but still rate of generation will be more than the rate of death. At this phase, tertiary phase, life is equal to death. More generation, birth is rate of growth is equal to rate of death. Endogenous phase, rate of growth is now least, death will be more. Okay. At the log phase, size will is always least. Other phases, size may vary, but at the lag, size is largest. Exponential, size is least. So this is how it is done. Moving towards the last question, sludge bulking can be controlled by. So for sludge bulking, F by M ratio, so much stress is given. So please read this part very properly. Sludge bulking can be controlled by, we have to select the correct option. There can be more than one option. By adjusting food by biomass ratio, reducing sludge is.
Option A and B, ma'am.
Okay, we'll see. Yes, very correct. Reducing sludge age, we have seen we have to reduce the endogenous and adjusting F by M ratio. It should not be too low and too high. So this is how it is done. So that's all for today. Any doubt in any of the question?
No, ma'am. It's clear.
Okay, then we'll close the session. We'll see you next week. If any case, if you have doubt in between, you can ask in the next session.
Ma'am,
Okay, ma'am.
Yes, yes, Vimal.
Uh, Ma'am, on last section, before you conclude, you leave one question, ma'am. What will we do by using the sludge on each and every step? What is the answer, ma'am?
Okay, okay. We'll discuss that question. So let's
Okay.
start. Um, when we talk about the primary system, so first step is, what is the first step? When we talk about the primary treatment, what will be the first step? Wastewater is coming. We have wastewater. So first step will be screening. After screening, water will pass, but there will be some sludge. And what type of sludge that will be? That will be big particles, big logs, big paper, big plastic. So screening sludge will go to the landfill. Second step is grid chamber. By the way, screening sludge is called screenings. Second step is the grid chamber. So there will be inorganic sludge that is also thrown to the landfill. So in these two, grid chamber and screening, we have no problem. We are not supposed to handle it. Now comes the third. Third step is primary sedimentation tank. Here we will get primary sludge. Fourth is secondary sedimentation tank. Here we get secondary sludge. So there are two ways to handle it. First, either we add them, we mix them together, or we treat them separately. So basically, what do we do with the sludge? Either we do aerobic treatment or we do anaerobic treatment. Secondary sludge, as in case of ASP and other things, is mostly biomass. Secondary sludge is mostly biomass. So we deal with it, like we want to deal with it very carefully, because these may contain some pathogens, these may contain anything. So there are basically two processes by which do we do treatment. If we are doing aerobic, it's fine, but if we are doing anaerobic, after that we do aerobic treatment also. So when after anaerobic we have to do aerobic, then why don't we do only aerobic treatment? Because in case of anaerobic treatment, we get some energy in the form of methane. So after doing all these process, whatever the sludge we get, we try to generate the methane. And sometimes in some smaller treatment plants, this much methane is sufficient to run the electricity of the whole plant. Whole plant can be taken care by this much methane. Next, what do we do? After that, after generating methane or after all the process, we will get some sludge. Still, we will get some sludge. So, in most of the places, if the nutrients are there inside that sludge, because this is domestic treatment, domestic wastewater treatment, so there will be some sludge. Then we will keep those sludge on the drying bed. What is drying bed? Drying bed is nothing, just a sand, a layer of sand, a thick layer of sand. Over that, we will place our sludge so the water can seep down and the sludge may remain under the sunlight. Then in some areas, we do this quite often in North India, there will be farmers, right? So we sell these cakes to the farmers, we auction it. So they will use this sludge, which is full of nutrients in their farm as in the form of fertilizer. So apart from water, we have a huge line. We have a very good line for the sludge. So these are the various steps. This I have explained in short. It has so many things. We can do composting also. We can, apart from this methane generation, we can generate hydrogen also. So there are various steps. So this is one of the basic steps. So this thing is very good. After drying bed, giving it to farmers so that they can use it in their lands, crops. And sometimes we will do secondary, tertiary treatment also. Tertiary treatment is also possible. But in that case, most of the sludge will be full of chemicals. Like if we want to remove the phosphorus, so we will put some chemicals to remove those sludge. So sludge handling in case of tertiary treatment is quite tricky. It depends upon the type of tertiary treatment we are using. In some cases, for removing the phosphorus, we do struvite precipitation, and struvite is very good fertilizer. But in some cases, we will just end up with huge quantity of sludge and we have no idea what to do with it. So again, it will go inside the landfill. So that is why the best use of sludge is done in primary sedimentation tank and secondary sedimentation tank. So this is how the sludge stream works. I hope you understood. Is there any doubt?
No, ma'am. Understood.
Okay. Then shall we close the session?
Yes, ma'am.
Okay. Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you everyone.